So continuing on in the second hour here with some more of our basic topics here. Let's get them knocked off the list. We're going to talk a little bit more about fractions. We mentioned the fraction having two parts, the count and the name. Not to go back to an elementary school concept, but the best way to describe a fraction, to define what that name of a fourth means, is to go back to the old picture of a pizza or a pie or however you want to look at it. A fourth means that every whole object is divided into 4 equal pieces. Or another way of looking at it is it takes 4 pieces to make one whole object. 3, of course, means that we have 3 of those pieces. One of the keys to working with fractions is to be able to rename them. The first and simplest way to rename them, if we're looking at the pizza, would be to just cut each of those slices into equal pieces. So let's say I cut each of those slices into 3 equal pieces. Now, how many pieces does it take to make a whole object, a whole pizza? Well, we had 4, and each of them got cut into 3, so 4 times 3 is 12. How many pieces do we have? Well, we had 3, each of those got cut into 3 equal pieces, that's 9. Do we have any more or less than we did before? No, it's the same amount. So one of the first ways we can rename a fraction is to multiply the top and bottom by the same thing. Technically what we're doing there is we're multiplying by 3 over 3. Well, that's saying we need 3 objects to make a whole thing, or 3 pieces to make a whole object, and we have 3 of them, or we have 1. And we all know that if we multiply by 1, we don't change the value. So we don't change the value, we just change its appearance. Now, the first thing that's involved in that is knowing what we want the name or what we want the denominator to be. If I have 2/3 and I want it to become 15ths, we have to ask, what do we multiply 3 by to make it into a 15? 5. So we have to do the same to the numerator, to the 2. 2 times 5 is 10. So 10/15ths is equivalent to 2/3. That works in the other direction as well. Well, let's take 48/64. Looking at that, it's really tough to visualize requiring 64 pieces to make a whole object and having 48 of them. But we can simplify that. Just like up here, we were able to multiply the top and bottom by the same number. We've said before that division and multiplication follow the same rules. So it makes sense that we could also divide the top and bottom by the same number. What's a number that we can divide both 48 and 64 by? 20 doesn't quite go in. Nice try, though. What can we divide them both by? Well, they're both even, so we know we can divide them by 2 at least. Let's try that. 48 divided by 2 is 24. 64 divided by 2 is 32. Good. Once we've done that, it's maybe a little easier to see that we can divide both of those now by 8. Good. 24 divided by 8 is 3. 32 divided by 8, 4. So we get 3/4. We might have, if you saw right away that you could divide both of them by 16, it would save a little bit of effort. You'd get to the 3/4. But you don't have to find the biggest number right away. A lot of us were told that you have to find the largest number that divides into both of them. That's not true. In fact, I could have taken the 48 over 64. We saw that's divisible by 2. The 24 over 32. They're both still even, so we could just keep dividing by 2 again. 12 over 16 and keep going. And we're still eventually, I apologize for my handwriting there, still eventually going to get down to 3/4. So we can rename a fraction by dividing the top and bottom by the same number. And we can do it repeatedly if we have to, as you saw here. We might have 25 over 40. What can we divide both of those by? 5. Perfect. 25 divided by 5 is 5. 40 divided by 5? 8. Perfect. So 5/8. We could double check. Can we divide 5 and 8 by the same thing? No, I've already circled it, so you probably guessed that we're done. So anyway, other things we can run into. We can run into something like this, 44/7. Now, we've already said the 7 means it takes 7 pieces to make a whole object. If we have 44 pieces, that means we have enough pieces to make more than one whole object. So to reduce this down, it'd be nice to split it up into whole objects and then the pieces that are left over. The way we can approach that is we can just divide 44 divided by 7. A fraction can be turned into a division problem, and the other way around. A division problem can be turned into a fraction. Now, if you punch that in your calculator, 44 divided by 7, probably going to give you like 6.2857143 approximately. What does that tell us? Well, it tells us that we can get how many whole objects out of the 44? 6. And it also tells us there's going to be pieces left over. To figure out how many pieces are left over, what is 6 times 7? 42. So we've used up 42 pieces. How many pieces are left? Out of 44, there's 2 pieces left. So that's 6 2/7. So our reducing a fraction like this is basically a division and a remainder. The vocabulary that goes with this is what's often called an improper fraction. There's nothing wrong with it. It's just we don't like having the numerator bigger than the denominator. And this is what was often called a mixed number. So to convert from an improper fraction to a mixed number is basically just that division and remainder. If we have 42/11, to reduce that to an improper, or to a mixed number, I should say, 42 divided by 11. 11 goes into 42 how many times? 3. 3 times 11 is 33. There are 9 left over. So that's 3 whole objects with 9 pieces left over. Those pieces are still 11ths. So 3 and 9 11ths. Oops. 27/5 becomes what? Perfect. 5 2/5. Same process. 27 divided by 5. It goes in there 5 times. 5 times 5 is 25. There's 2 left over. So that's where we get the 2/5. We can go the other direction. Sometimes we need to go from a mixed number into an improper fraction. To do that, all we're really doing is taking these 3 whole objects and breaking them into pieces. Well, how many pieces does each of them have? Because this is 8, each of them has 8 pieces. So that 3 whole objects is 3 times 8, or 24 pieces. Combine that with the 5 other pieces that are there. 5 and 24 makes 29 eighths. If we have 7 2/3, what's that going to become? 23, perfect. 7 times 3 is 21, plus the 2 is 23. Okay, enough of that. Let's get to working with our fractions a little bit. We saw earlier 1/3 plus 2/5. We couldn't add those because they had different names. So the first step we have to go through is how do we give them the same name so that we can add or subtract them? Well, the simplest way is to just make lists. You're looking at multiples of 3, 3, 6, 9, 12, 15, 18, and so on. The 5, well, you know that counting up by 5s is 5, 10, 15, 20. So I can look at this list here and realize the 15 is the first number that both of those would go into. Another possible way, not always the best way, but it works, just multiply them. 3 times 5 is 15. In this case, it gives us the same number, but it won't always do that. By the way, you've always been told you have to find the least common denominator. That's not necessarily true. Any common denominator will work. It's just the least common denominator is the least amount of work. So it's easiest if, oops, my connection's going bad here. It's getting blinky up there. Easiest if we set them up vertically. 1/3 plus 2/5. Our common denominator is going to be 15. So just like we just did, what do we multiply the 3 by to make it into a 15? 5. So 1 times 5 is 5. What's this going to become? 6. 5 times 3 is 15, so 2 times 3 is 6. And we add. 5 and 6 make 11/15. Now I'm not going to spend any more time with examples of simple fractions. I'm going to move on to mixed numbers. We might have 3 and 5/8 plus 7 and 1/5. Again, I'm going to set these up vertically. Notice I lined up the fractions just like they're the last digit of a number, because that's really all they are, is the last digit of our number. We still have to find that common denominator, or give them the same name. So the 3 and the 7 won't change. What's our common denominator going to be for 8 and 5? Careful. It's 40. 40 ends up being our least common denominator there. So what's this going to become here? 25. Good. 8 times 5 makes 40, so 5 times 5 is 25. How about here? 8. Perfect. 5 times 8, so 1 times 8 makes 8. So we go ahead and add. Just like with our whole numbers, we start on the right and work our way back to the left. 25 plus 8 is 33/40. 3 plus 7 is 10. Now, it's not always that simple. We can run into ones like this. So let's set this one up. Again, the 2 and the 5, the whole numbers won't change. What's our common denominator going to be? Now, yeah, 6 times 4 would be 24, but in this case, there's a smaller one we can use. We can use the 12. What's going to go here? 10 and 9. Perfect. Here's where it gets to be a little bit more difficult. When we add these, we have 10/12 plus 9/12, which is, of course, 19/12. What's wrong with that? It's an improper fraction. So we can turn it into a mixed number. It would be 1 and... Take 12 out of there. 7/12. Perfect. So just like with whole numbers, we're going to keep part and we're going to carry part of it. We're keeping the fraction of 7/12 and we will carry the 1. 1 and 2 makes 3 plus 5 is 8. That's 8 and 7/12. On to subtraction. For subtraction, I'm not even going to bother with simple fractions. We're going to jump straight to whole numbers. So just like with our addition, we're going to set them up vertically. The whole numbers, again, are not going to change. What is our common denominator going to be here? 15. Good. What's this going to become? 10 and 9. Perfect. So again, just like whole numbers, we start on the right and work our way back to the left. 10/15 minus 9/15 is 10 minus 9 is 1/15. 8 minus 5, 3. So 3 and 1/15. Just like with the addition, it doesn't stay that simple. We have 9 and 1/4 minus 2 and 3/8. So once again, the 9 and the 2 won't change. What's our common denominator going to be? 8. In this case, one of the denominators is already the common denominator. So the 3/8 is not going to change. This is going to become 2/8. Now when we go to subtract, 2 minus 3 can't be done. So what do we have to do? We borrow from the 9, that'll become an 8, just like borrowing in whole numbers. But here's the tricky part. What we borrowed was just one whole object. How many pieces are in that one whole object? 8. So what we're really adding to the 2 is 8 more pieces. This is now 10/8. So let me pause there for a second. Anybody that has any questions where the 10/8 came from? Okay, so 10 minus 3 is 7/8. 8 minus 2 is 6. So 6 and 7/8. Let's do one more example of that. You guys talk me through this one. I'll put in the 7 and the 4. What do I do next? Common denominator? 24. Perfect. What goes here? 9 and 20. Okay, now what? Borrow from the 7, that's a 6. What do we do here? We add 24 because that one whole object we borrowed has 24 pieces in it. 9 plus 24 is 33. And then we subtract. 33 minus 20, 13 24ths. 6 minus 4 is 2. 2 and 13 24ths. Any questions? Okay. Multiplication. We might have something like 1/4 times 2/5. We saw earlier when we multiply, we just multiply straight across. Combine the counts and then also combine the names. So 1 times 2 is 2. 4 times 5 is 20. Now at this point, you see that we can do what with that? We can reduce it. Both the 2 and the 20 can be divided by 2 to give us 1/10. Now some of you might have been looking at that thinking he could have cross-canceled right away. Right about now, some of you might be wondering what is cross-canceling. Some textbooks call it cross-multiplying. What it is simply a way of reducing the fraction before you multiply. We know that this is going to become 1 times 2 over 4 times 5. And if you happen to see that both the 4 and the 2 can be divided by 2, you can reduce before we multiply. You could cross-cancel the 4 with the 2 to get 1 and 2. And now when you multiply, 1 times 1 is 1. 2 times 5 is 10. You get the reduced answer right away. Now in a problem like this, it's about the same amount of work to do it either way. But we could run into problems like this one. Where we could multiply this out and reduce, but 24 35ths is going to be, what, like 840? So 24 times 35 is 840. 25 times 36 is like 900. Then we could reduce that. Or we could do the cross-canceling and reduce it before we multiply. Pretty simple, pretty easy to see that the 25 and the 35 can both be divided by what? 5. Which will give us 5 and 7. 24 and 36 can both be divided by 12. Good. If you didn't see the 12, just like reducing any other fraction, you could divide by 2 and then 3 and just keep going. So 24 divided by 12 is 2. 36 divided by 12 is 3. And now we can multiply. 2 times 7 is 14. 5 times 3 is 15. You get 14 15ths. If you were to reduce this, you'd end up in the same spot. If I were reducing that, I'd see the 0 on the end. I'd probably reduce by 10 first to get 84 over 90. And then I see that both of those can be divided by 2. 42 over 45. And then both of those can be divided by 3. Have you ever seen how to tell if a number is divisible by 3? How I can look at that and see that 42 and 45 are both divisible by 3 really quickly. if you add the digits together, what's 4 plus 2? 6. Can that be divided by 3? Yes. Then 42 can be divided by 3. Same with 45. What's 4 plus 5? 9. That can be divided by 3, so 45 can be divided by 3. So you can really quickly tell if something's divisible by 3. That only works for 3. Actually, it works for 3 and 9, but 9 doesn't matter because you can just divide by 3 twice. So you can tell if it's divisible by 3. 2's, of course, if it's an even number, it's divisible by 2. How can you tell if something's divisible by 5? Ends in a 0 or 5. So if you can get those 3 out of the way, usually you can get it down to something small enough where you can see what else it divides by. Yeah, well, 6 is just divisible by 2 and 3.
Right.
Yeah. There's all sorts of rules. There's rules for 11 and 13 and stuff like that, but they get to be so complicated it's easier just to try to divide them out. Yeah. That's enough with just the simple fractions. Let's get on to mixed numbers here. Let's do 5 1/4 times 7 2/3. To multiply mixed numbers. Actually, multiplying mixed numbers in itself is a very difficult process. If you were to grab 10 math majors and ask them how to multiply mixed numbers, I'd actually be willing to bet that none of them could show you the right way to do it. Because of that, we cheat. We just don't multiply mixed numbers. Can anybody tell me what we do to avoid it? We make them into improper fractions. Exactly. This is going to become how many fourths? 21. 5 times 4 is 20 plus 1 is 21. This is going to become how many thirds? 23. Perfect. 7 times 3 is 21 plus 2 is 23. And now at this point, just like any other fraction, we can cross cancel. Is there anything here we can cancel out? 21 and 3 can both be divided by 3 to give me 1 and 7. 7 times 23 is 161. 4 times 1 is 4. And then we can reduce that just like any other improper fraction using division and remainder. 4 goes into 16 4 times, with nothing left over, bringing down the 1. 4 does not go into 1, so we put a 0 there. There's 1 left over, 1/4. So that is 40 and 1/4. Out of curiosity, does anybody want to see how to multiply the mixed numbers? One of you? Well, let's do it. I've got time. You don't have to write this down because I will never ask you to do it. Not unless you really upset me before the end of the semester. But let's just go through it. Just like if you have 23 times 54, you have to do the 4 times 3 and the 4 times 2. Same thing applies to mixed numbers. We have to do the 2/3 times the 1/4, but we also have to do the 2/3 times the 5. So let's start out with the 2/3 times the 1/4. Of course, we can cross cancel the 2 and the 4 to get 1 and 2. 1 times 1 is 1. 3 times 2 is 6. Now the 2/3 times the 5. How do we multiply a fraction by a whole number? Put it over 1. Now it's a fraction. 2 times 5 is 10. 3 times 1 is 3. That is 3 and 1/3. Now we have to do the 7 times the 1/4. Once again, we put that over 1. 7 times 1 is 7. 1 times 4 is 4. So that is 1 and 3/4. And then we have the 7 times 5, which is just 35. Now we have to combine all this. To do that, we need a common denominator, which is going to turn out to be, what, 12? So 1/6 is 2/12. 3 and 1/3 is 3 and 4/12. 1 and 3/4 is 1 and 9/12. And then we just have the 35. 2 and 4 is 6, plus 9 is 15/12, which reduces to 1 and 3/12, or 1 1/4. Keep the 1/4. Carry the 1. 1 3 is 4, plus 1 is 5, plus 5 is 10, 0, carry the 1. 40 1/4, we get the same answer. Now, like I said, I'll never force you to do that. I don't dislike you guys that much. From here on out, we're going to turn them into improper fractions. One more example of that, and let's move on to division. You guys talk me through it. Not everybody at once. What do I have to do first? 5 times 2 plus 1. So 5 times 2 plus 1 is 11 fifths.
5 times 3 is 15, plus 2 is 17 over 3.
Perfect. 5 times 3 is 15, plus 2 is 17 over 3. Can we reduce anything? Can we cross cancel? No, there's nothing we can cross cancel, so we're going to multiply. What do we multiply first? 11 times 17, 87, and 5 times 3 is 15, which is going to give us 12 7/15. We would do that as a division and remainder again. 187 divided by 15. 15 goes into 18 once, with 3 left over. Bring down the 7, goes in there twice, with 7 left over. So 12 7/15. Any questions? Okay. Just like with whole numbers, division with our fractions is the one operation that has been altered the most. We said that division follows the same rules as multiplication. When we multiply, we just multiply straight across. So if I want to divide fractions, could I divide straight across? Can I do 12 divided by 4 is 3? 25 divided by 5 is 5? Does that work? Well, is this the right answer? Yeah, it is. Does that work to just divide straight across? Sure it does. Will it work every time? Well, if it works out, yes. Why don't we do it that way? Well, because we run into things like this. 2/3 divided by 3/4. If we were to try to divide straight across there, 2 divided by 3 is not going to work out well, is it? What have we been taught to do to divide those? Multiply by a reciprocal. We take the number that we're dividing by, the 3/4, and we use something called a reciprocal, or we just flip it over, 4 over 3. The 2 over 3 then, the 2/3 is multiplied by the 4/3. 2 times 4 is 8, 3 times 3 is 9. You get 8/9. How did we get to this process from this here? Again, this is just a little bit of math history. You don't need to write it down. I won't ever ask you to repeat it, but just to show you where it comes from. Once upon a time, if I were to do 2/3 divided by 3/4, we would look at this second fraction, the 3 over 4, and I would take 3 times 4, which is 12. Now I would use that 12 to rename my first fraction so I could divide. So I'm going to take my 2/3 times 12 on top and on bottom, which is going to give me what? 24 over 36. Now that I've done that, of course, 24 over 36 is the same as 2/3. I'm going to divide that now by 3/4. 24 divided by 3 is 8. 36 divided by 4 is 9. 8/9. How did we get from doing this to dividing by a reciprocal? Well, at some point, somebody noticed that if instead of, basically what this was 2/3 times 12 over 12 divided by 3/4. And what they noticed was, if we were to divide first, do the 12/12 divided by 3/4, what we get is always this fraction flipped over. And then, of course, it's just multiplying from there. So that multiplying by reciprocal is just a shortcut of this longer process. Now, again, I'm not going to ask you to change anything, but sometimes it's nice to know where things come from. I'm a math geek, so that's interesting to me. I see it on your faces like, yeah, it's not interesting to any of us. Okay, that's all right. You guys all realize you're just here to entertain me for 3 hours a week, right? Okay. As long as we understand that, we'll be okay. So let's divide our mixed numbers. 4 1/3 divided by 2 4/5. Well, since we're just going to change them into multiplication, it makes sense that we would do the same thing we do when we multiply. We're going to turn them into improper fractions. What's this going to become? 13/3. And this one will be 14/5. Now, we would not be able to cross cancel here because it's still division. What do we have to do before we can think about cross canceling? We have to do the reciprocal here. This is going to be 5/14, and now it's multiplication. Well, we still can't cross cancel anything, so we're going to multiply. 13 times 5, 65. 3 times 14, 42, which is 1 and 23/42. One more example. We'll have you walk me through it, and then we'll put an end to our fractions. Tell me what to do. 2 times 3 plus 1 is 7 halves. Perfect. Okay, 8 times 4 plus 3 is 35/8. This is still division, right? What do we have to do next? Okay, the 7 halves, the number we're starting with doesn't change. It's the number we're dividing by. We take the reciprocal, 8/35, and now it's multiplication. Then what? We can cross cancel. 2 and 8, both divided by 2 to give me 1 and 4. Is that it? No, 7 and 35, both divide by, careful, 7, give me 1 and 5. So we get 4/5. Any questions? Okay. Now I'm going to show you a neat little trick. How many of you have a calculator with you tonight? Okay. Pull out your calculator for a second. Depending on which calculator you have one of 2 buttons on it. Either the ABC button or just a button that looks like this that has like a generic fraction on it. If the Texas Instruments has the ABC, the Sharp or the Casio will have this one on it, depending on what model you have. If I want to do, let's do this 3.5 divided by 4 3/8. Can I get somebody to shut the door there in the Richmond so we don't have to listen to the vacuum cleaner? Thanks. To enter this, let's just enter 3.5 into the calculator first. To enter that in the calculator, using the ABC key, it's 3, then you press the ABC key, then 1, and the ABC key again, and then 2. That is 3.5. Does anybody have a different key than the ABC key?
I don't have either.
And the graphing calculator won't have either.
No, you have to go to math and
Yep.
actually use parentheses and
Yep.
things, make a fraction.
And that'll actually automatically change it to an improper fraction, so you'll have to reduce it down and then from there. So if we wanted to do this problem, we're just going to use that process to enter it in there. So entering the 3.5 and then the 4 3/8. So you do all this, then hit divide, and then do the same thing with the 4 3/8. you get to come up 4/5? Perfect. Anybody not get it to work? We have questions?
How do you enter that in with if you don't have that key?
Let me see your calculator. What do you have?
It's more complicated than that.
The business calculator. That does all your amortization and stuff like that, but it won't do fractions. Sorry about that. Okay. Next thing we want to look at before we completely tie up fractions is let's look at our fraction to decimal conversions here. To review our place values, this of course is the ones, tens, hundreds, thousands, 1,000, sorry, 10,000s, 100,000s, and so on. As we go to the other side of the decimal point, we look for a pattern. As we move one decimal point to the one decimal place to the right, our place value is divided by 10. Each time, 1,000 divided by 10 is 100, 100 divided by 10 is 10, 10 divided by 10 is 1. So as we keep going, those place values keep dividing by 10. 1 divided by 10 is 1/10. 1/10 divided by 10 is 1/100th, and 1/1000, and so on. Now you can see these place values look suspiciously like fractions, because that's what they really are. A decimal is nothing more than a shortcut way of writing a fraction with denominators that are powers of 10. So if I have 0.32, what that really is 32 hundredths. That 2 is in the hundredths place, so our denominator of our fraction is 100. Now if I were converting that decimal into a fraction, I wouldn't leave it like that. I would reduce it because both of those can be divided by 2. If I have 0.0125, to convert that into a fraction, it's going to be 125 over, can anybody tell me? Tenths, hundredths, thousandths, and 10,000ths. A quick little trick: 1, 2, 3, 4 decimal places. 1, 2, 3, 4 zeros in our denominator. Both of those can be reduced by what? 5. Give me 25 over 2,000. Both of those can be reduced by, they can be divided by 5 again, but they can also be divided by 25. Gives us 1 over 80. So going from a decimal to a fraction isn't so bad. We can run into something like this. How do we handle that 8 in front of the decimal point? Well, just like with our fractions, we can have mixed numbers. With our decimals, we have mixed numbers. That 8 is a whole number. It's the 0.45 that we have to convert. It's going to become 45 over 100. And of course, we can reduce that by 5 seems to be the common theme. 9 tenths. All done? But I forget. Gotta keep that 8 there. Going from a fraction to a decimal, just as easy. I'm just going to divide. 3 divided by 8 is 0.375. What if I have 5/7? What's that going to become? How do I do it? 5 divided by 7, which is going to be 0.714285714 approximately. Everybody get that? Okay. Any questions? Okay. I've been flying right along. It's a little early for our second break, but let's take our second break quick. We'll come back and we'll get through order of operations and stuff, and then we'll get out of here a little early tonight.